One last problem should do it. This is the last one. Okay, so in this last problem, we have a very complexified logarithmic equation, and our goal is to solve for the letter Z. Z, alright? So Z is Z. So now let's solve for the value of Z. To solve for the value of Z, this is going to be a very easy thing to do. Okay? But this one's so complexified because we have so much logs in there. However, thanks to the good news that I told you about, we can apply the game called condensing and expanding logarithms. So going back to our review, how do you apply the laws of exponents when it comes to logarithms? So laws of logs, like for example, if we have log ABC, you can expand this by writing it as log base A, log A plus log B plus log C, right? That is the sum law. For example, if A were 1, if A were 1, if B were 2, if A were 10, if B were 100, and if C were 1000, that if we were to apply the 10 times 100 to give you 1000, and 1000 cubes gives you 1 million, and then you get 6, right? Because log base 10 of 10 and log base 10 of 100 plus log base 10 of 1000 gives you, this is 1, this is 2, and this is 3. This gives you 6. And log base 10 of 1 million is 6, right? Now let's try the quotient law. The quotient law is this. If we have, for example, we have log and then A, B, and C. Let's say, for example, if A were 10, and if B were 10 din, and if C were 100, remember we have the sum, the difference of logs, or let's say A, we can write that as log A, log B, pair whatever on the denominator, that's C. That's negative, so log C. So let's say, for example, if A were 100, so that's 100, right? And then this becomes log B, that becomes 1000, right? 10 minus log 1000. So this one becomes, what does this one become? Log 2, and this becomes 1, and this becomes, 3, right? Log base 10 of 1000 is 3. So 2 plus 1 minus 3 is just 0. So that cancels out. And even if we were to do that, we get 1. Log base or we were to do something like this. Diba, remember it goes like this, 100, 1000. Diba? This one becomes 1000, and 1000 over 1000, the log cancels, and it becomes 1. So log, anything raised to the log of 1 is 0. So therefore it's 0. Tama. Now, the last one is what you call the power law. The power law, like for example, if we have this, log C, then raise the D power, the D is brought to the log. So it goes like this, right? For example, if we have this one, log base 2 of 4 cubed, right? Take note that the cubed will be dropped down here, and this will be 3 times log base 2 of 4, right? And log base 2 of 4 is just 2. And 3 times 2 gives you 6, right? So that's the law of logarithms. Or if you were to do something like this, 4 cubed gives you 64. And log base 2 of 64, this gives you 6. See? It works that way. Or if you were to shrink the exponent, you can shrink this 4 into 2 squared. And then applying the power law, you can just multiply the exponents to give you 6. Log base 2 of 2 cancels, and you're just left with 6. So that is the power law. Okay? Now you already know the laws of logarithms. So to help you answer item number 50, let's apply the laws of logarithms and to help us solve for the value of Z. Because this one implies the application of expanding and condensing logs. So let's write the equation down. So it says here we have negative 2 times log base 10 of z minus the same thing, log base z minus negative 5 log base z again is equivalent to log 1 plus log z. Okay? Now, what do we do here? First, we need to apply the laws of logarithms that I told you before. We need to condense it. So remember, we expanded a logarithm, and this is how we expanded, but now we're going to shrink it. So that negative 2, remember it's right here, right? What do we do to this one? We bring it to the numerator, we bring it to the exponent to write it as the simplest form. Very good. It goes like this. So now it becomes log base z of negative 2. And then this one again, this negative 2, is brought to the top. Pero, it's plus, diba? So plus log base z of negative 2 again. And then we have this negative 5. So this negative 5 log of z is minus. So log base z of negative 5. Right? And it equals to log of 1 and plus log of z. It's the same as 1z. Or just simply z. Log z. Right? Pero we can simplify this furthermore. Diba remember, this is the product law. This is the product law. Log 1 times z is equivalent to 1z. We don't need to write 1 anymore because we already know that 1 is already implied. So yan. Now for the left side, we can still simplify this further. So remember, this is already product and quotient law. So we write log, and then this becomes z raised to the negative squared, and then times z raised to another negative squared again, and then minus log base z of negative 5. It's on the bottom, right? Because it's subtraction. And it's equivalent to log base z. Right? Then, look at this. Our bases are all equivalent. So therefore, goodbye logs. Now, all we have to do is to just apply the laws of exponents to help us solve for the answer. Very good. To apply this, remember all the logs cancel. And now we're just left with z raised to the negative 2 times z raised to the negative 2 divided by z raised to the negative 5 equals just z. Z raised to the first power. Now applying the laws of exponents. Negative 2 plus negative 2 equals negative 4. So therefore, this is equivalent to z raised to the 4th power divided by z raised to the 5th power. Negative 5th power is equivalent to z equals 1. Then, all we can do, can we simplify this further? Yes. So z raised to the negative 4th power, if we were to write that as an expanded form, we can write that as 1 over z times z times z times z. Just like that. 4 times. And on the denominator, we have 1 over z times z times z times z times z. Right? Equals 1. Equals just 1z. Pero apply reciprocal. Applying the reciprocal, we have z, 4 z's on this side, 1 over this guy. And then multiply, we have 5 z's on the other side, on the numerator. Divide by 1 equals just to 1 z. Now remember, anything thanks to the identity property of multiplication, anything multiplied with just 1 is just with self. So therefore, you have 5 z's on the numerator. Z. Parang natulog na kayo. Ayoko na talaga matulog. Parang kayo mag-bored na ka na dito. Matulog na kayo. Mga boy kayo. And then this one, right? And it's equivalent to just 1 z. Now we can cross out how many z's are there. 1, 2, 3, 4. There are 4 z's being cancelled. And z equals z. Wait a minute. There's no variable. What is the variable of z? Ha! Tricked you. You know why? Because you thought you're supposed to solve for any solve for the value of z, right? But to be honest, Remember, on the right side, I said that it's log base 10 of 1 plus log base 10 of z. So that's just log base z. So therefore, the z can depict as any number that you want, for as long as we can't have negative values. So let's say, for example, if we use 10, let's try to put that into our equation and find out what will happen. Getting your calculator ready and see if we get the same answer. So this is how we're going to do it, all right? For example, let's put here the log -2 log base 10 minus 2 times log base 10 minus -5 times log of 10. What do we get? 1. And take note, log, and that's the answer, right? We get 1, right? On the same time, we have log 1 plus log of 10. We got the same answer. How about let's try other numbers? Let's say, for example, if it were -8. So -2 times log of 8 minus 2 times log of 8 again. Can you see what I'm doing? Minus -5 times log of 8. We get this answer 0.903 something, or 0.9. Now let's try it with on the other side. Log base 10 of 1 plus log of 8. You still get the same answer din. How about let's try kung fraction naman? Kung fraction. Let's say, for example, do you remember you have -2 log? -2 times log of, how about let's try 20 over 30? 20 over 30. 20 over 30. Just like that. Minus 2 times the log of the same answer again. 20 over 20 over 30. Minus -5 times the log of 20 over 30 equals -6.7889 something. Now let's try it with it's equivalent to log base 1 plus log base 10 of 20 divided by 20 over 30. Wow! We still got those funny answers. Pero that's not right kasi nga we cannot have fraction. Kasi dapat we're supposed to get the answer kasi eh. Diba kanina we're supposed to get 1.6 something? But it's just that we have wrong computation. Pero, just like or maybe let's just simplify the fraction para mas mabilis. Yan. Or if you like, para mas mabilis, we can just simplify the logs. We just write it as one single log, and then we say, this guy (20 over 30) raised to the -2, raised to the -2, and then times 20 over 30 raised to the -2 minus, and then it's subtraction, right? So it's minus 5, this guy again, 20 over 30 raised to the -5th power. We got that answer, right? Same pa rin. Kaya that's why nga, if we have this can be depicted as any variable. So therefore, in the last number, z can represent any number, any real number, for as long as it's not a negative number. Let's try naman kung negative number. Let's verify naman. I-verify na namin. Let's say, for example, kapag negative number ilagay namin. Like, halimbawa, let's try negative, ano yun? -1. Let's try -2, diba? -2 raised to the -2 power. And then we do the same thing again. -2 raised to the -2 power. Just like that. And all divided by -2 raised to the negative 5 power, right? You get none because you cannot take the log of any negatives. So automatically it becomes none. That's it.